My name is Tom Thompson, and I will discuss aircraft attitude indicators, sometimes referred to as the artificial horizon. The attitude indicator is one of the primary instruments for safe aircraft flight and is normally located upper centrally on the pilot's panel. The attitude indicator is one of the family of gyroscopic instruments. Two other examples of gyroscopic instruments are the turn coordinator, or turn and bank indicator, and the heading indicator. A spinning object can exhibit the properties of a gyroscope. An aircraft gyroscope must have significant weight for its size and the least friction as possible. Then it will freely rotate about its center of gravity. One property of the gyroscope is rigidity in space. The gyroscope is mounted so that it is free to move in any direction, but it remains stable in the plane which it originally started spinning. A second property, precession, allows its reaction to a force applied to be measured. Note the gyroscope's stability. The artificial horizon uses these properties of a mounted gyroscope to move an instrument that looks like the earth below and the sky above. Here, we see an attitude indicator in its case and a picture of the primary parts. The gyroscope needs to be driven at high speed in order to rotate at an effective speed. Originally, this was accomplished using a vacuum of air created by a Venturi. There are problems with this pressure source in terms of maintaining enough airspeed and problems in possible icing conditions. Small general aviation aircraft now use an engine-driven pump to create the vacuum. The vacuum relief valve in the system prevents any positive pressure in the line from damaging the instruments. A filter ensures clean airflow. The artificial horizon stands out on the instrument panel with its blue sky and aircraft wings simulated on the horizon. While the engine is running, this instrument will stay in its plane of rotation by using the vacuum air that we discussed. Here we see an aircraft in level flight on the left instrument. The center horizontal lines indicate the angle of pitch, and the lines in the circle above the horizon indicate the angle of attack. In the instrument on the right, the aircraft is in a climbing right turn. Some modern aircraft are fitted with attitude and heading reference systems, or AHRS. Instead of mechanical input, the AHRS gets its aircraft movement information from three pieces of equipment which can feed an electronic display seen here. The three AHRS inputs are a magnetometer, which measures the Earth's magnetic field for location, a gyroscope for roll, pitch, and yaw, and an accelerometer for measuring linear motion. Although glass cockpits have their own artificial horizon, you can see in these examples that the Federal Aviation Administration still requires a standard artificial horizon as a backup. That concludes my discussion of attitude indicators.